See, the procedure is like this. First, we build the functional dependencies, and then we build the tables. But now I'm just asking you, if a table is given to you, and if this table is valid according to all the constraints, then what are the functional dependencies you can rule out? So after giving a table, we can rule out some of the functional dependencies, as they might not have been be there at the first place, but we'll not be able to guess what are the functional dependencies which have already been there. Are you following it? See, given a functional dependency, later we try to add some attributes into the add some tuples into the tables. But now the question is, given the table, right, what are the functional dependencies that you could guess might not have existed, but then you will not be able to guess what are the functional dependencies definitely would have you would have derived from the requirement analysis. Okay, I'll just take the examples, it will be clear, right? Now watch it. Rule out the functional dependencies based on the tables, which means if this table is true, if this table is allowed by DBMS, your software, then what are the functional dependencies that you can rule out, and what are the functional dependencies that you might have to leave for further examination, right? See this, EID determines ename. So is it right or wrong? According to this this particular three entries, if you watch EID determines ename, you are seeing that EID is always unique, right? So whenever left hand side is always unique, right, you can think that this is valid as far as this is concerned, right? Therefore, see, simple, EID has to determine ename. Given any EID, you have to come up with a unique ename. Since EID itself is unique, given any unique one, you will be able to say only one name, right? You are not going to say two. For example, if they say that EID equal to 1, what is ename? Then you will say ename is A. EID equal to 2, what is ename? You will say B. EID equal to 3, you will say B. Got it? So whenever any EID is given, your answer will always be one answer. Got it? Therefore, maybe this functional dependency would have existed earlier. I'm not sure that it is definitely there, but then I cannot rule out. Depending on this, I cannot rule out. Okay. And now, what about this one? Can I rule it out? See this? Given a value of ename, will you be able to say a unique EID? See, if ename is A, I'll be able to say EID is 1. But if ename is B, right, I'll not be able to say a unique EID. Got it? Therefore, this one doesn't exist. In case if this one would have existed, you would never get this case, right? So at the first place, this functional dependency would not have been existing, and therefore it is not a constraint. It has not been applied on the DBMS as a constraint, and so these tuples are allowed, right? What about this? I'm not sure. As of now, I'm not able to rule it out. Maybe in future that it might be possible that we might have to rule it out. For example, see, in future what might have happened? What might happen is, maybe if they enter one more tuple 1 and let us say C, then what happens? Given an EID, I'll not be able to come up with a unique ename. Therefore, I'll rule out it, right? Therefore, I need some further examination. I cannot guess it as of now. As of now, I cannot rule it out. It doesn't mean that it definitely exists. Got it? And you might think that, is it possible at all that two attributes are having same value, and here also two attributes are not having same value, and there is no primary key at all? It is not possible. In case if we had other attributes also, I am talking about only these two particular attributes, then it is possible. Okay. So anyway, what I wanted is, if this particular table is possible, what are the things you can rule out, right? So I could definitely rule out it, but I cannot say anything about it as of now. As of now, it seems as if, oh, this must be true, but later it might change, right? Unless I know the requirement analysis, I'll not be able to say exactly. So based on the tables, I can only delete some of them as invalid. I cannot only rule out. I cannot say anything specifically. Okay. What about this? See this table. Given a value of A, will you be able to say a value of B uniquely? Given a value of A as 1, I'll not be able to say the value of B, because a value of B can be 1 or 2. Therefore, I can rule it out. If this table is valid, then this functional dependency wouldn't have existed. If this functional dependency would have existed, right, and if this is applied as a constraint on the table, then you'll never get this type of values. Now what about this one? Given a value of b, will you be able to come up with a unique value of a? Given a value of b, yes. If the value of b is 2, what can you say about a? A can be 1 or 2, therefore you have to rule it out also, because you are not able to come up with a unique value of a. Got it? Now let's see this one, right? So here both are ruled out, right? This one, yeah. Now let's see this. In this one, a determines b, which means given a value of a, will you be able to come up with a unique value of b? Just check this. If a is 1, b can be 1 or 2, right? Therefore I am not able to uniquely come up with a value of b just for this case, so I need not do any further probing. I can just rule it out here. And what about b? Given a value of b, can you come up with a unique value of c? Given a value of b, right, can I come up with a unique value of c? If b is 1, right, c is going to be either 4 or 3, right? Therefore it is also ruled out. What about b derives a? Given a value of b, will I be able to come up with a unique value of a? See this, if b equal to 1, a can be either 1 or 2, not possible. What about c derives a? Given a value of c derives b. Given a value of c, will I be able to come up with a unique value of b? It is not possible. See this, because when c is 4, b can be either 1 or 2, so it is not possible. What about this? Given a value of c, will I be able to come up with a unique value of a? Yes, it turns out yes. Check this. Given a value of c, so only two values are possible here, right? So what are they? 4 and 3. If the value of c is 4, then always the value of a is 1. If the value of c is 3, then always the value of a is 2. Got it? Therefore, yes, this is okay. As of now, I cannot rule it out. Maybe, and I am not sure whether it is true or false, because I don't know the requirement analysis, right? So I cannot rule it out. That is what I am sure. I cannot say anything further, okay? Because later some kind of addition might violate this functional dependency also. Therefore, I cannot directly declare that this functional dependency exists, because only some part of the table is given. Later some additions might be done to this table, which might rule out this one also, right? Now as of now, okay, a derives c. Is it possible? Given a value of a, will you be able to derive c? C. If a value is 1, yes, c value is 4. If a value is 2, yes, c value is 3. Yes, these two I cannot rule out now. So all these things I can rule out as of now. Okay. Now what about this one? This question is given in GATE 2002. Just see this. What are the things that you can rule out? Given a value of a, can you rule out? Can you get a value of b uniquely? When a is 1, yes, b is 1, and when a is 2, yes, b is 3. Therefore, given a value of a, I am uniquely getting a value of b. So as of now, I will not be able to rule it out. I can't say anything about this, but I am not going to rule it out. Okay. What about b derives c? Given a value of b, you should get a unique value of c. But if b equal to 1, c can be 1 or 0. So it is not holding, it can be ruled out. This wouldn't have existed. In case if this would have existed, then I will never get such a tuples, right? Okay, what about this one? X, z, you are supposed to get x, right? Given a value of x and z, you are supposed to get a unique value of x, obviously, right? Because it is a trivial dependency, isn't it? So trivial dependency always holds whatever it is, because if you give a value of x and z, you will always be able to get a value of x, isn't it? If you give the value of x and z as 1, 3, what is the value of x? 1. If you give the value of x and z as 1, 3, what is the value of x? 1. If you give the value of x and z as 4, 3, value of x is 4. 3, 2, value of x is 2. So trivial dependencies always hold. What is trivial dependency? Left hand side is a superset of right hand side. That is trivial dependency. So trivial dependency always holds. You need not worry about it. It doesn't just depend on the table, or whatever is the requirement analysis phase, you need not worry about it. Trivial dependencies definitely hold. Okay, whatever is the requirement analysis. Next one is xy derives z. So given a value of xy, so xy is 1, 4, xy is 1 6, xy is 4 6, xy is 3 2. And one more thing, in a table, if the left hand side is unique, which means if they are saying that, like this case, see this, xy is unique, right? 1 4 1 5 4 6 3 2. In a table, if left hand side is unique, right, then obviously whatever is the right hand side value, you can say that it doesn't violate at all. Violations will occur only when left hand side attributes are having two same values and the right side attributes are having two different values. Then only violation will occur. As long as left side values are distinct, which means no two attributes have the same values on LHS, then there is no way it is going to violate, right? So this one will never violate as of now, right? So as long as this x and y values are unique, I can never rule it out. Okay, what about z? Watch it. Yes, since the values are repeating, the left hand side value is z. Since it is repeating, there is a chance that there might be violation, right? Where will be violation? For the same values of z, if we have different values on right hand side, z to y, which means for a given value of z, you should get a unique value of y. It is not possible, right? Because when z equal to 3, y value has taken 3 different values, therefore it can be ruled out, right? Okay, let me cross it off. So sometimes ruling off is also doesn't determine. Okay, this, if you want to rule it out, you just strike it off like that, right? Doesn't determine. It is actually useful in theoretical exams, not in GATE. These notations, conventions and all. Okay, and next one is y determines z. So y value, if you watch it, y value is actually unique, right? So whenever left hand side is unique, you need not check it. It will never get violated. Violation will occur only when left hand side is same and right hand side differs, right? And x and z. So x and z, yes, here there are unique values, right? So x and z 1 3 1 3. You have to check only those values which are repeating. You need not check the values which are unique, right? So which means 1 3. If x and z are 1 3, right, y is taking the value of 4 and 5. Therefore this one is clearly violated, right? So how many violations are there? This one got violated and this one got violated. This one definitely holds because it is trivial. And what about this? I can't say about it and I can't say about it, which means as of now they seem like yes, they are true, but then I cannot derive that information only based on the table. I need the requirement analysis, right? Unless I know the requirement analysis, I'll not be able to say rule out them, or I'll not be able to accept them. Okay, only thing I'll be sure is some functional dependencies are not possible. That's it. Okay, let's watch this. Now A determines B. So A is actually unique, right? So whenever there is unique, there is no way it will get violation, right? So it is fine. And what about BC? Check the combination of BC. Yes, in BC there is repetition, 2 3 here, 2 3 here, right? So given a value of BC, A value is 1 and 4. For the same value of BC, A is taking two values, it is a violation. So it will never occur. Now B and C. So B is actually repeating. Just go through the repeating values only, right? So here it is, repetition is there. Now B determines C. So whenever B is 2, is the C value 3 same? Yes, C value is same. Therefore it seems like it holds true, but I'm not sure as of now. Now AC determines B. What about AC determines B? Just check the values where there are repetitions. So 1 3 4 3 5 3. AC values are not repeated anywhere. 1 3 4 3 5 3. Therefore there is no possible violation, right? So as of this table is concerned, as far as this table is concerned, I'll rule out only this FD, and all the other FDs they hold, right, as of now. But I don't know exactly they really hold or not unless I know about the requirement analysis. Got it? Okay.